Hello, everybody. In today's lesson, we're going to start Module 15, and we're going to work with finding volume and surface area. And specifically in Lesson 15.1, we're going to be working with what is known as nets and finding surface area using nets. So a net is basically just a two-dimensional representation of a prism or a pyramid. Basically, you take a prism and if you cut it apart and lay it flat, you'll see the different shapes of that prism. So a net is a two-dimensional pattern of shapes that can be folded into a three-dimensional figure. The shapes in the net become the sides or faces of the three-dimensional figure. So for instance, on your graph paper, copy each of these nets and then cut out each net along the blue lines. So you can pause the video while you create your nets. So I have already prepared mine. Okay, so there's net A, and that's net B. So go ahead and create that. Okay, the inside lines are the black lines, and around the outside is the blue. Okay, so we're going to cut along the blue to create our nets. Okay, now if you're ready and you have your shapes, one of these nets can be folded along the black lines to make a cube with no open sides. Which net will not make a cube with no open? Okay, so let's look at A. Okay, so fold along the black lines. Okay. So this part makes the bottom of my cube. It comes around. So there we have the 5 sides, and then this side's going to close. So I am able to make a cube out of that prism, out of that net. Okay, so B apparently is one that we're not going to be able to make a prism out of, or a cube with no opening. So again, fold along the black lines. And then try to put it together. All right, so we're folding along the black lines. You see that this part on this one folds down. It's going to be on the inside. It's not going to be making anything. So here we have the 4 sides. I fold this down, and so it looks like a cube, right? But when I turn it over, that other one was folded down inside. Okay, so net B, we cannot make a cube out of it without an opening. Okay. All right, now on your graph paper, draw another cube that you think would work. Now, my best recommendation for figuring this out and to see it is imagine unfolding the three-dimensional shape. Look, when you're looking at the cube, right, we have a top, a bottom, a left, a right, a front, and a back, right? So mentally unfold that cube. Okay, so this is what I came up with. Okay, first off, we have to have 6 squares, right? We have to have 6 faces for it to be a cube. All right. And so when I'm looking at this, I would call this the bottom, or it could be the top too, top or bottom. This would be my left side, my right side, my front, my back, and then this other side is going to be folded over. It'll be the opposite side, whether you call it top or bottom. So if we fold along these lines, okay, so we make a clear box from that. and then the top one folds over to complete the cube. Okay. Now that's not the only way to do it. Okay, that's the one I came up with. So I'm actually not going to give an answer for B, okay, because I obviously don't have a class with us here, okay. So you can compare that with classmates or um, try on your own, try out some different methods, okay. So we know there's at least two, right? Because net A is different than the one I drew. Okay. So you have to see if you can come up with a different way too. All right. Number one, how do you know that each net, numbers 1 and 2, cannot be folded into a cube with no open sides without actually cutting and folding it? Well, number one, I don't even have to try to fold it mentally. 1, 2, 3, 4, 5. It's missing a square. All right, 2. All right, so again, if we're folding along the black lines, okay, so we fold that up, and we fold that up, fold that, fold that, fold that. Well, there's not going to be a top or bottom. It's just going to make a like a loop. Okay. All right. So let's move on. Now, being able to visually see these three-dimensional shapes and unfold them, it takes practice. Okay. It may be a little struggle at first. Okay. But continue to practice, take them apart, look at different images. Okay. Number 3, suppose you cut up a rectangular cereal box along its edges. If you lay it flat, what shapes will you see? Well, I actually have a cereal box that I have cut up. Okay. So if I unfold it, okay, you really can't see the image right there, right? Maybe if I zoomed out a little. Okay. You see that this is the side of it, right? This is the front. This is the back, right? So if we put it back together, this is the side, the back, the front, and then we also have a top and a bottom, right? So we would have 6 rectangles. Is it possible to have a cube as a cereal box? Sure, but squares are rectangles, so no matter what, we still have 6 rectangles. Okay. All right, so keeping that in mind, that we have different shapes, different faces, and different shapes of bases and different faces, we're going to use that idea to find the surface area of the whole shape. Okay, by mentally unfolding it or actually drawing the net. So let's look at surface area of a pyramid. The surface area of a three-dimensional figure is the sum of the areas of its faces. A net can be helpful when finding surface area because we're laying it out like in this shape here. So we see that it has a square base. And so if it has a square base and we have 4 triangles going around it, okay, we would call this a square pyramid. Okay. So I can find the area of the square here. Okay. I know that if this side's 16, this side has to be 16. Okay, because it's a square. All right, and so that means the bases of all the triangles is also the same. So the base of this triangle is 16. The base of this triangle is 16. The base of this triangle is 16, and so on. And then they're also giving us the clue that the height of this triangle is 17. So is this one, so is this one, and so is this one. Well, we know how to find the area of a square. We know how to find the area of triangles. So all we have to do is find the area of each face and add them together. That's all there is simply to do in finding surface area. So here's the example. Make a net of this square pyramid and use the net to find the surface area. All right, so this was our 3-dimensional shape. They unfolded it, right? So if you were to cut along the edges, it would unfold and you'd get flat triangles connected to a square. Okay. So the square base, there would be a triangle on each side, and we're going to label the dimensions. So this arrow here is pointing to the height. Okay. This is the base of the triangle. So there are 4 triangles with a base of 16 and a height of 17. Well, how do we find the area of a triangle? 1/2 the base times the height. So 4 times the area of one of the triangles. All of these triangles are equal in this case. Okay, well, half of 16 is 8. 8 times 17 is 136. And 36 times 4 is 544 inches squared. So that's the area of the triangles. The area of the square is 16 times 16, or 256. 256 okay. So all we have to do is add up all of those add-ins, basically. Okay, so we're going to add 544 plus 256, and that gives us an answer of 800. All right, so let's try one of our own. Use a net to find the surface area of the pyramid. Okay, so again, we have a square base, right? So let me get a piece of paper to draw it out. I might as well try to be exact here. Okay. So that's our square base, and they're telling us that the sides are 16. And then we're going to have 4 triangles. So the base of all of these triangles is 16, and the height will be 20 inches. Okay, so now let's figure out the area of these. So the triangles would be area equals 1/2 base times height. Well, we have 4 of them, so we're going to go 4 times 1/2, 16 times 20. Well, I'm going to take half of 20. Half of 20 is 10, and 10 times 16 is 160. So 4 times 160 gives us 640 inches squared. Okay, again, we're finding area, so the unit will be inches squared, or the units will be squared. And now we need to find the base of the triangle, of the square. The area of a square is s squared. So 16 times 16. So 256 inches squared. Okay, now just add those two together. 640 plus 256 will give us 896 square inches. So again, all we did first was find the area of each of the triangles, and they were 160. The square was 256, and so we just added up all of these. So rather than go 160 plus 160 plus 160, I multiplied it by 4. That gave me 640, and then I added it to the area of the square, giving me 896 square inches. All right. So think of surface area as like wrapping paper. We want to cover the whole present, right? So we want to go around the outside or the surface of the gift. All right. Page 423, surface area of a prism. Same idea. Okay, we're just going to unfold the prism and add up the areas of the different faces. So a prism is a three-dimensional figure with two identical and parallel bases that are polygons. So the bases have to be identical. The other faces don't have to be identical, but the base does. All right. So a prism is identified by the shape of its bases. For example, a triangular prism, the reason we call it a triangular prism is it has triangles as its bases. And in the Go Math book for 6th grade, all the prisms we encounter are what are known as right prisms, which means that the faces that are not bases are rectangles. All right, so example 2. A sculpture sits on a pedestal in the shape of a square prism. The side lengths of a base of the prism are 3 feet. The height of the prism is 4 feet. The museum director wants to cover all but the underside of the pedestal with foil that costs 22 cents per square foot. How much will the foil cost? Okay, so we have a square prism. So we know that we have a bottom. We're going to have 5 sides. Okay. But he's not going to cover the bottom. Okay, so there would be one more side here if we were unfolding it and doing it all. So that's why there's only 5 sides here. Okay, because it says all but the underside. Okay, a square prism, another word for a square prism is a cube. All right, so use the net to find the area that will be covered with foil. Well, look at these. You notice that the square, I take back what I said about rectangle, a square prism being another name is a cube. In this case, it wouldn't be a cube because I look at the rectangles and the rectangles are not equal. Okay, they're not all 3x3s. So this is a square prism. Okay, with made up of a square base and 4 rectangles. All right, so the area of the top is 3 times 3. The other 4 faces are identical. They're 3x4s. Okay, so we have 4 of those, right? 4 of those rectangles that are 3x4. So multiply 4 times 3 times 4, and that would give us 48 square feet. Now just add the area of the 4 rectangle faces and the area of the square, and it gives us 57 square feet. But the actual question says, how much will the foil cost? So we had to figure out the surface area first, now multiply that by 22 cents, and now it come out to $12.54. So the foil will cost $12.54. All right, so number 5. What shapes would you see in the net of a triangular prism? Okay, again, the reason it's called a triangular prism is that's the shape of the base. So I'm going to see 2 triangles. Okay, and then earlier on the page it says that in this book, all the prisms in our book are considered right prisms, which means that the non-base faces are rectangles. So if there's 2 triangles, there's 3 sides, right? So I have to have 3 rectangles. Okay, let's look at page 424. Number 6, the figure shown is a triangular prism. How much would it cost to cover the bases and the other 3 faces with foil that costs 22 cents per square foot? All right. So this one's a little trickier because it's not as obvious what the height of the triangles are. Okay. But we do know that the bases are triangles, right? You would agree with that, right? And then the other 3 faces are rectangles. So let's draw a net and let's go ahead and put the triangle here. So what we're doing, in a sense, doing is I'm going to unfold it so that the triangles are on like the top and bottom of my paper, and the rectangles will be to the sides. All right, so the base of my triangle is 4, and my height, I'm going to go ahead and write in 3. Okay, so that's the triangle. So the triangles are 2 times 1/2, 4 times 3. Now the rectangles. So when I unfold these, this part right here, that's this shape here, and that is a 2x5. So I can write in 5 and 2. And I guess I can call this rectangle 1. Or I could call it the front. Okay, the front. And then we have 2 sides, right? And this side, if we're looking just here, we see that the top is 3, so the bottom would also be 3. So it's 3 times 2. I'm sorry, rectangle 1 was 5 times 2. Rectangle 2, I'm going to call this rectangle 2, rectangle 1, rectangle 3. Okay. Rectangle 1, rectangle 2, rectangle 3. All right, rectangle 2 is 2 by 3, and rectangle 3 is 2, because this side is 2, so this side also has to be 2 by 4. 4 times 2. All right, so now let's figure out surface area of these. So 1/2 of 4 is 2. 2 times 3 is 6. 6 times 2, 12 feet squared. 5 times 2, 10 feet squared. 2 times 3, 6 feet squared. 4 times 2, 8 feet squared. Now add them all up. 12 and 10 is 22. 22 and 8 is 30. 30 plus 6 is 36 feet squared. Okay, so that's the surface area. But they want to know how much it's going to cost. So it would be 36 times 22 cents. $7.92 would be the cost. All right, number 1. A square pyramid is shown. Okay, so the figure has, since it's called a square pyramid, the base is a square. So it has one square base. Find and how many triangular faces? Well, there's 4 sides to a square, so there has to be 4 triangular faces. All right, find the surface area. The area of the base. Okay, well, the base is a square, so 6 times 6, right? 6 times 6, 36 inches squared. The area of the 4 faces. Okay, so the base is 6, so let's go 1/2 base times height, and we're going to multiply that by 4. Why are we multiplying by 4? Because there's 4 identical triangles. Okay, so 4 times 1/2, 6 times 4. Okay, well, 1/2 of 6 is 3. So 4 times 3 times 4, which is 48. 4 times 3 is 12. 12 times 4 is 48. So the surface area is 36 plus 48. All I did was I went back and wrote in this numbers that we found for this surface area. Again, each of the triangles is 12 inches square, so 4 times 12 is 48. The area of the square is 36. So add up all the areas of those faces, and we come up with 84 square inches. Okay. All right, number 3. Yolanda makes wooden boxes for a crafts fair. She makes 100 boxes like the one shown, and she wants to paint all the outside faces. So she wants to find the surface area. So find the surface area of one box. Okay, so that's going to be the bottom. Okay. The side is 6 by 4. So the other side is also 6 by 4. Okay, so I'm going to go ahead and write this in. So this is, I'm going to call this the bottom. Okay, that's this part right here. And I see that that's 10 by 6. Yeah, 10 by 6 because we're doing the bottom. Okay, the top is right here. And that's also 10 by 6. Okay, what about the front? Here's the front. And that's 10 by 4. 10 by 4. So this is the front, this is the back, and it's also 10 and 4. Now we have the left and the right side, which are 6 by 4. Okay, so now we can figure out the surface area. So top, bottom would be 2 times 10 times 6, right? Because there's 2 that are identical. Front and back would be 2 times 10 times 4. So 10 times 4. And the left and the right, 2 times 4 times 6. All right, well, 2 times 60 is 120. 2 times 40 is 80. And 2 times 24 is 48. Add those up. 8, 14, 248 square inches. So 60, 40, 40, 60, 24, 24. Okay. So again, 2 times 40, 80. 2 times 60, 120. 2 times 24, 48. So find the total surface area of 100 boxes. Well, that would be 248 inches squared times 100. Well, we know anytime we multiply something by that ends in zeros, all we have to do is place that number of zeros in the answer. So 248 followed by 2 zeros. So 24,800 square inches. 1 can of paint will cover 14,000 square inches. How many cans of paint will Yolanda need? Well, 14,000 plus 14,000 is 28,000. All right, so 2 cans would be plenty. 1 can's not enough. 2 cans is right. All right, and number 4. How is a net useful when finding the surface area of prisms and pyramids? Well, basically, it comes down to being able to see all of the faces and the dimensions on those faces so that we can add them up when we find the area of each face. So So what I said simply put is basically what I'm trying to say. A net, such as this, shows the three-dimensional figure as flat and two-dimensional, which makes it easier to visualize the shapes of the surfaces and to be able to add up their areas. All right, so let's go ahead and pause there for part one. In the next video, I'll discuss the independent practice with you. So until then, I'll see you soon.